friends, myself Shoptaporni from BioLife. Today we will learn about pituitary. This is my third video on endocrine system. My previous videos are on hormones and pancreas. You may also check out that videos. The links are in the description box below. And if you like my content, please like, share and subscribe my channel to stay updated. I post regularly videos on different topics of class 9, 10, 11, 12 and undergraduate level. So please subscribe. Okay, let's begin. Pituitary or hypophysis is located at the base of the brain and it is situated in a small saddle-shaped cavity of the sphenoid bone known as sella turcica. See here, it hangs from the base of the midbrain and below the hypothalamus. This blue portion is hypothalamus and this yellow gland is pituitary gland. The slender infundibulum, this slender infundibular stalk attaches the pituitary gland to the hypothalamus. You can notice that it is a very small sized gland, almost like a pea, and it weighs only about 0.5 gram. It is called master gland of our body. Why? Because it controls all other major endocrine glands of our body. So this is an elaborative view of the pituitary gland. Here you can see this yellow pituitary gland composed of two main parts, anterior pituitary and posterior pituitary. Posterior pituitary is composed of a slender stalk-like infundibulum which attaches the pituitary to the hypothalamus at the median eminence. Whereas another part of the posterior pituitary is pars nervosa, which is composed of neuronal cells. That is why it is named as pars nervosa. Whereas the anterior pituitary is composed of three parts. A tube-like portion known as pars tuberalis, this yellow portion, which surrounds the infundibulum like a collar. A median portion between the posterior and anterior pituitary known as pars intermedia. This portion is pars intermedia and the rest portion is known as pars distalis. And you can also see this is the sphenoid bone and this is the fossa of the sphenoid bone known as sella turcica, inside which our pituitary gland is situated. Now, what are the different hormones produced by the anterior and posterior pituitary? First hormone produced from the anterior pituitary is growth hormone or GH. Then thyroid stimulating hormone or thyrotropic hormone TSH, gonadotropic hormone or gonad stimulating hormone. Under this family there are three hormones: follicle stimulating hormone or FSH, luteinizing hormones or LH and interstitial cell stimulating hormone or ICSH and prolactin. And the last but not the least, adrenocorticotropic hormone or ACTH. Whereas the two hormones produced from the posterior pituitary are Antidiuretic Hormone or ADH and also known as vasopressin and Oxytocin. Let's see what are the main functions of these hormones. See, from the anterior pituitary, growth hormone is secreted which acts on the muscle cells, bones and adipose tissues and regulates the normal growth of our body. TSH acts on the thyroid gland and controls the secretion of T3 and T4 from there. Whereas the adrenocorticotropic hormone acts on the adrenal cortex, this portion of the adrenal gland, and from there it regulates the secretion of glucocorticoids, mainly cortisol and sex corticoids, androgens. The gonadotropic hormones FSH, LH and ICSH stimulates the secretion of estrogen, progesterone and testosterone respectively from ovary and testes. Whereas the prolactin acts on the mammary gland and causes milk production in the alveolar cells of the mammary gland. See, these cloud-like structures are known as alveolar cells where milk is produced and stored. Two hormones secreted from the posterior pituitary are ADH or Antidiuretic Hormone, which acts on the distal convoluted tubule of the nephron. It also acts on the blood vessels. And another one is Oxytocin, which causes muscle contraction of the mammary gland and uterus. Now, coming to the first hormone, growth hormone or somatotropin. It is secreted from the anterior pituitary and its main function is body growth. How? It acts on the bones, cartilage, adipose tissues and other various types of tissues of our body to stimulate overall growth of our body. Now, we have learned from our previous lesson that hypo or hypersecretion of any hormone may lead to disease conditions. So, deficiency of growth hormone in childhood causes dwarfism, which is stunted growth of a baby. See here, if this is a normal person, it is a dwarf person with a stunted growth. On the other hand, if there is oversecretion of growth hormone in childhood, long bones get lengthened up beyond the normal level and the person becomes gigantically tall. See here, this is a person with gigantism. See, you may have learned that or heard that from your parents that after a certain age you don't get tall. What happens? In our long bones there is two portion known as epiphysis. In this epiphysis, cells divides and that is why our long bones get lengthened. But after a certain age, it could be your late teens or early 20s, then your epiphysis gets ossified and no cell division can occur there. As a result, your long bones cannot lengthen after that. That is why we don't get taller after that age. But if there is a oversecretion of growth hormone in your adulthood, what will happen? Your long bones cannot lengthen now. So they will get they will grow sidewise. That is why in acromegaly there is excessive growth of chin bones, hands and feet, and there is also a large nose, thick lips, etc. This is an acromegalic person. Now coming to the tropic hormones. See, what are the tropic hormones? Tropic hormones are those hormones which stimulate other endocrine glands to produce their specific hormones. Mainly, hormones secreted by the anterior pituitary are tropic hormones. See here, from the anterior pituitary, TSH, ACTH, FSH and LH or ICSH are secreted. TSH acts on another endocrine gland, thyroid gland, and regulates the secretion of T3 and T4 from there. So you can say that TSH is a tropic hormone. Similarly, ACTH acts on adrenal cortex and regulates the secretion of cortisol and androgens from adrenal cortical cells. Whereas FSH and LSH and ICSH all acts on either ovaries or testes and regulates the secretion of estrogen, progesterone and testosterone. So all of these four hormones, TSH, ACTH, FSH and LH or ICSH, acts on different endocrine glands and regulate their secretion of specific hormones. So they are all tropic hormones. Now The second hormone secreted from the anterior pituitary is thyroid stimulating hormone or TSH, which acts on the thyroid gland to produce T3 and T4. The third hormone is adrenocorticotropic hormone. It is named such that because it acts on the adrenal cortex as a tropic hormone, and from there it stimulates the secretion of cortisol and androgens from the adrenal cortex. The third group of hormones secreted from the anterior pituitary is gonadotropic hormone, and it regulates the activities of gonads. The first hormone is follicle stimulating hormone. It has main three functions. See, this is a cross section of ovary, and inside this ovary you can see various size of different circles which are representing the ovarian follicles at different stages of development. Inside each ovarian follicle you can see a black dot which is the ovum or egg. So, follicle stimulating hormone stimulates the growth and maturation of these ovarian follicles, and it also stimulates the ovarian follicular cells to secrete estrogen. On the other hand, in males, it stimulates the sperm formation in the testes or spermatogenesis in the testes. The second hormone is luteinizing hormone, which acts on the ovary and causes ovulation. See, when a mature Graafian follicle or when a mature ovarian follicle or a Graafian follicle gets ruptured and ejects its ovum in the uterine tube, that process is known as ovulation. And without LH surge, this ovulation is impossible. And after the rupture of the ovarian follicle or Graafian follicle, it gets converted into a yellow colored body known as corpus luteum. See, here is the corpus luteum from which progesterone is secreted. In case of male, the ICSH causes the interstitial cells of Leydig of testes to secrete testosterone, whereas the prolactin signals the alveolar cells of the mammary gland to produce milk and store it in the alveoli. See, these cloud-like structures are the alveolar cells of the mammary gland. Now, antidiuretic hormone is produced from the posterior pituitary. It has main two functions. First of all, it stimulates the reabsorption of excess water from the urine in the descent of nephron. That is why we don't excrete excessively dilute urine. We always excrete concentrated urine. That is why it is known as antidiuretic hormone. Another function of this hormone is constriction of blood vessel. See here, the blood vessel is constricted and thus it helps in rising the blood pressure. That is why it is known as vasopressin. But what will happen if there is a deficiency of ADH in our body? Obviously, less amount of water will be reabsorbed from the DCT, and as a result, we will excrete dilute urine which is tasteless. Why tasteless? Because in case of diabetes mellitus, due to presence of glucose in the urine, it tastes sweet. But here is no glucose in the urine, but the urine is excessively dilute. That is why it is insipid or tasteless. See, as large amount of water is excreted out through urination, the person feels excessively thirsty. The feeling of excessive thirst is known as polydipsia, whereas the frequent urination is known as polyuria. So, a diabetic patient always pees a lot and also drinks a lot. Now, the second hormone secreted from the posterior pituitary is oxytocin. it stimulates vigorous contraction of the uterine muscles during the childbirth, and it also stimulates ejection of milk from the alveolar cells of the mammary gland where milk is stored. How milk is ejected? See, when a baby starts suckling her mother, or his mother, that suckling signals goes to the brain into the posterior pituitary, and then from the posterior pituitary oxytocin is released, which causes the contraction of myoepithelial cells which surrounds the alveolar cells of the mammary gland, and due to this muscle cells contraction, alveolar cells ejects the milk, and that is how oxytocin works. Now, what is feedback mechanism? See, secretion of any hormone is regulated by feedback mechanism. A feedback mechanism is nothing but a loop in which the end product of the cycle or the loop, that is mainly a hormone, feeds back to control its own secretion. Okay. So, that could be of two types, either negative feedback mechanism or positive feedback mechanism. Negative feedback mechanism is more common and most hormones are controlled through this. See, our body has a normal state or homeostasis. Our body always tries to maintain that homeostasis. But if there is any deviation from that normal state, our body tries to restore that normal state. How? Either it increases the action which has been lowered, or it tries to decrease the action which has been arisen. So, this kind of feedback for the opposite action is known as negative feedback mechanism. See here, from the hypothalamus, thyroid releasing hormone or TRH is secreted, which stimulates the secretion of TSH from the anterior pituitary, which again stimulates the secretion of thyroxine from the thyroid gland. But if there is excess amount of thyroxine in our blood, we don't need the secretion of much more thyroxine. So what will happen? Then thyroxine will either negatively stimulate or inhibit the hypothalamus to decrease the secretion of TRH, so that the secretion of TSH is also get slow, and as a result thyroxine secretion will also be low, and the level of thyroxine will get low in the blood vessel. Or on the other hand, it may directly inhibit or negatively regulate the anterior pituitary cell to lessen the amount of TSH secretion, so that thyroid secretion gets low. And by this both process, the level of thyroxine gets lowered in the blood when the thyroxine level gets increased. So, the another mechanism is positive feedback mechanism. What happens? In this loop, the end product or the hormone tries to amplify the action which causes the deviation from its normal state, instead of going back to the normal state. How? See, our uterus is normally uncontracted, but during the childbirth, when the baby's head pushes the cervix of the mother, a signal goes to the posterior pituitary and tells the posterior pituitary to secrete oxytocin. That oxytocin then stimulates uterine muscles to contract, and this contraction of uterine muscles positively feedbacks our posterior pituitary to release more oxytocin, so that more contraction could be produced until the delivery is complete. So, here this is a positive feedback mechanism because it amplifies the secretion of oxytocin, which is not a normal state in our body. So with this we come to an end of our today's lesson. Thanks for watching. Please like, share and subscribe. Happy learning!